Hello students, welcome back to the Yupp Master. So today we are going to take that different methods for measurement of physical quantities. Let's see. We have discussed in the first class about that units and measurements. What are the measurements? What is the need and importance of measurement? Now if you are going to look into that matter, you can see, different methods for measurement of physical quantities. All right? Yes, everybody has to see that. So, do you agree measurement is going to be a one process? All right. It involves different steps. If you are going to take that, what is physical quantity? Physical quantity. Suppose you know a measurable quantity is known as physical quantity. Known as physical quantity. It's very clear. Right? Now, if you are going to take that, a measurable quantity means, can you measure the mass? Can you measure the time? Can you measure the speed? Let's see. You can measure the speed of this car. You can measure the distance covered by the car. See? You can measure that. Yes. You can measure that speed. This is the speed of the car. This is the distance. Yes, you can see that. It's going to be identified that this is the distance. These are all the measurable quantities. So they are known as physical quantities. All right. Have you understood that matter? What is physical quantity? In the universe, we are going to measure some quantities. Simply quantity means how much, that we have to take that. But you have to express that in terms of one standard unit. Right? Okay. In order to get that, some properties like that, physical properties, mechanical properties, all these, you need to get that measurement. In order to estimate the strength, in order to estimate the speed, you need to measure the time and you need to measure the distance covered. You can take that distance covered in time t. In time t, 1 second. Let's see that. It's very clear. Again, if you are going to take that, it's going to cover that some distance. That should be V2 and T2. So this is a physical quantity. In our daily life, have you seen that we are going to get that observation of a body which is in motion, which is in one-dimensional motion. Very clear. Now here also distance. This is also distance covered. Yes. Distance covered in time t2 seconds. T2 seconds. Very clear. I hope you can able to measure some quantities. Suppose you have taken that the surface area of amoeba. Can you measure that surface area? This is not possible because it's going to be change its position. It is going to be irregular position. Do you know that? Can you observe that the movement of octopus? Yeah, if you are going to measure that total surface area of the octopus, you can't measure. But here it is going to move in one dimensional. Let's see that this is along one dimensional, 1D motion. Yes, you can measure that. Say along x-axis it is moving. Right. Here what are the fundamental quantities that you need? You need length and time. So it is for distance. Yes, to represent. Very clear. In our daily activities we are going to measure some physical quantities. So measurable quantities are known as physical quantities. Suppose I am going to take that, does the speed is depend on any other factor? All right. Sure, it depends on how much distance does it has been covered in the time. So it depends on the different parameters. If you are going to take that engine capacity, the fuel type, and the amount of heat generated, so many factors are there. So the speed is a one physical quantity depend on other quantities. So it is derived quantity. Later we will see that, right? We have been measured that distance covered by the body in a time t seconds. Now you can take that average speed. Average speed is equal to, yes, you can take that total distance by total time. Yes, easily you will find out that. That is, you will find out that d by t1 plus t2. Alright, you can measure. This is one method we can use. Suppose next you can take that. Yes, have you seen this one? Previously you have taken one dimensional. Please remember all the students. What happened? Let's see. Yeah, it's going to be light. It's going to be light. Yeah. It emits the light rays in all the directions. Light is emitted in this direction. Yeah, in this direction. Yes, this is one direction, this is in another direction. Emits light in different directions. Let us assume. Right. Now if you want to get that in the view of 3D per a unit square area, this area, how many light rays are entered? You have to get this. Yes. You can take that these emitted light rays are moving in all the directions. What about the previous case? That car, it has one dimensional motion. Along one dimensional you can easily measure that. Here also we can measure. For that purpose we have taken some quantities which are known as supplementary quantities. That is, you can take that angle. If you are going to get that solid angle, you are going to get that solid angle. You will take that. Just you can see the light is emitted in all the directions. So in this particular area you have to imagine. I will show that from the source the light rays are emitted here. Yes, all right. Now you can imagine. Yes. Yes, you can take that all the direction. Light from the source, the light rays are emitted in all the direction. That is 0 degrees to 360 degrees. We are going to pick that at particular area. Just you can take that solid angle. We are going to take that solid angle. Suppose if you are going to take that plane angle, very easily you will find out that it has some inclination. That motion has been along 2D. Just you will go for 2D, just it is going to be x and y. Yes, you can easily find out that theta, which is going to be easily find out that. But it is going to be in the three-dimensional view. Example, from the source of the light rays are emitted. At that time we will go for solid angle. From that source they are emitted in this. For unit area in the view of three-dimensional space, we are going to take that solid angle. You know, intensity of the light is depending on per unit area how many light rays are entered. We can measure easily, right? So it was used to express that candela. Candela is the unit. Just we are going to take that. In this way we can measure. For the measurement of some quantities, we have taken some supplementary units. What are the supplementary units? We can take that solid angle. This is very clear. I hope so you can understood that what is that plane angle and solid angle. Very clear. Let's see. Yes, this is 1D. Very clear? No problem, you can easily identify that. You can easily measure that speed and force and acceleration. With respect to the direction applied force, you will find out that. You will take that, right? This is the case. We can know that. Yeah, we will like to know that. Yes, easily we will identify that. Depending on that, the description of a phenomenon in our daily life, we can easily identify that. This is a method. Example, irregular shape, amoeba, leaf. We can get this measurement, regular cube. So if you are going to take that amoeba, yeah, it's going to be, yeah, yes, if you are going to take that, yeah, you can take that leaf area, its area is measured by graph paper. Easily you will find out that graph paper. Suppose you have taken that one leaf, let us, yes, you can take that, yeah, easily you will identify that. You have taken this leaf, you can take that. So with the help of graph paper, you will identify that. You can take that one square box. So one line is equal to 1 mm. In the graph paper, just you will take that one line. How many lines, how many square boxes completely occupied? So you can add that. So you will take that one box, it's going to be 1 mm square. Easily you will find out that area can be measured very easily. You will find out that. What about amoeba? That's going to be most irregular. You can't measure. But regular shape, you will measure that cube, regarding to cube and square. Alright. So this is the one method we can use that. We are talking about the different methods. You can take the thread also. By taking the thread, you will get this measurement. Yeah. So area is going to be measured. Area. Now, if you are going to take that another one, you can measure that. Yes, here volume. Easily find out. All these are the different methods. You can easily find out that. Right? Let's go for another one. Need of measurement. Yes, in order to estimate the physical properties of matter in our daily life, measurement is necessary. Very clear. Right. Let's go for another one. Importance of measurement in physics. Let's see. Yeah. Now, if you are going to know about the importance of measurement in our daily life, if you want to get the properties of matter, that its behavior is going to be absorbed and the matter is going to convert in the energy, you can easily identify that. You will take that matter. It has size, shape, right? So conversion, matter is going to be getting that conversion. So energy, released. So in our daily life we are going to have that different activities. Meanwhile, all our needs are going to have some dependency on other parameters. So if you are going to get this physical world, so many interactions are there. At each and every interaction, you need to get that conversion, energy released, how the mass is converted into energy. If you are going to get that one form of energy is going to be converted into another form. All these are about to know the properties of matter. Right? What is the matter? Just you know very well about that. Matter has different forms depending on the distance. Right? You know, if you are going to take that matter, yeah, you will take that solid, liquid, solids, liquids and gases. Yes, it is very clear. We will discuss about this all. These are having that regular shapes, shape of container, these are right. So you can measure that. Nah, this is very, very important. Yes. In our daily life, we are going to have that observations and the practical approach. We are going to have that practical approach that easily estimate that what are the changes occurring around us. Yeah. Now it is very clear. We can know that importance of measurement. Just we will take that for measurement of any quantity, we will choose a constant quantity as a standard, right? We will compare this standard unit with other one. All right. Now, if you are going to get that quantity means how much, how many. If you are going to get that quantity in terms of a particular amount, so you need to express the value, you need to express that quantity in terms of a standard unit. You can choose one standard unit and it is going to be reproducible. All right. Now, let us go for this one. We can easily understood that matter. What we are going to know about that? Yes, we are going to have, this is a one special case. We are going to discuss about that supplementary quantities. Yeah, this is going to be plane angle. This is going to be plane angle. This is going to be plane angle. This is going to be solid angle per unit surface area. You are going to be getting that solid angle. This is going to be solid angle. Please note that in the view of 2D, in the view of 3D, what we have discussed. So, it is very clear. From the light source, what we have seen? Yeah, we have taken that from the bulb. So, there exists emission of light, what we have seen. Yeah, we are going to get this solid angle. Yes. The angle subtended by the unit area in the view of 3D. Yes, with respect to the 3D space, the angle subtended by that unit area with respect to the 3D space, that is known as solid angle. Easily we will identify that, right? Now, if you are going to get that motion around the nucleus, around that one planet, easily you will find out that angular displacement also. You have to get that angular displacement. Easily you will identify that. That is delta theta, delta t. You will get that angular speed. All these parameters are going to be measured in the different ways. All right. So, let us go for another one. Yes, we are going to see once again. It's very clear. The light intensity can be measured with the help of the solid angle. All right. Right. Let's go for area. Right. If you want to get that measurement of area, yeah, you need to know about that radius. You need to know about that radius. So, you will measure this area can be measured. You can take the thread, you can span that thread around it. Yeah, this is the thread. You have been measured that object very simply, right? It's a circumference is equal to, identified that, suppose circumference is going to be 52 centimeter, let us assume. So you can take that 2 pi r is equal to 52 centimeter. You know, r is equal to 52 by 2 pi, that is 52 pi 2 into 3.14 centimeter. Easily you will find out. At the time you can take that thread and scale. Yes, this is one we would like to know about, that simple measurement, easily we can measure. Therefore area is going to be, yeah, we can take that, yeah, area of the circle can be measured very easily, that is pi r square. By using the simple technique we can measure the area of circle by knowing the thread length, what it has been covered. You should put on the paper, right? Should put the thread, we can take that, this is a scale, simple measurement, you will take that, the thread has been taken and measured that, this is the thread, you know its value. This is a one process, you can easily measure that. You have to learn how it is going to be. Yeah, this is going to be circle. Yes, r is the radius. Alright, we should know about that. This is a one method. With the help of thread and scale you can measure that area of the square, volume of the cube, easily will measure that. You can total surface area of that one room also you will measure. Very simple instruments. Okay, these are all the measurable quantities. Area, it is a derivable quantity. It's a one derivable quantity based on that radius. And we have to know that formulas. Right? Let's go for another one. This is also, we are going to get this. Yeah, we are going to know about this cone, and we would like to get this. Yeah, base. We can get that slant height, and we can easily measure that all these problems. So it is a one process. Measurement is a process which involves in the various steps to identify and observe that and represent with the different parameters and choose the correct formula for the shape. If you are going to get that, it's going to be cone. You will easily identify that. Yes. Now let's go for another one. Yeah, it's going to be complete body. Yes, you will identify that. Yeah, cylinder, you will find out that cylinder. So its base, height, you want to get this one. Yes, you will take that. This is a top area, top layer. It is also in the form of circle. You measure that area pi r square. It is going to be multiplied with the height. You will get that volume. So you have to take that. These are the different process to get that measurement. Right? At your lower classes you can identify all these things. Okay, all of you, please have that continuous monitoring and watch the videos and all these things. Thank you very much. Have a nice day.